Hello friends, welcome back to my YouTube channel. This is Ramdas Pandit Bharsat, working as Assistant Professor in Chemistry at Maratha Vidyaprasarak Samaj, Nasik. And in this video lecture, we are going to study about hydrolysis of salt of strong acid and weak base. Now, consider the example hydrolysis of ammonium chloride is a sort of strong acid and weak base. Okay, and when ammonium chloride dissolves in water, it undergoes complete dissociation. Okay, so NH4Cl you will take into the water, so it will dissociate in this way. NH4Cl, okay, NH4 plus Cl minus. In this way you will get ions, separate ions, cations and anions. And while ammonium ions will react with some of the OH minus ions from slightly dissociated water to produce freely dissociate ammonium hydroxide ions. Okay, so NH4Cl if you will take into the water, so what will happen, it will dissociate like this. Okay, and water also can dissociate H plus and OH minus ions, so that NH4 plus ions will accept OH minus ions, so it will form NH4 OH. Okay, NH4OH, so that will be the ammonium hydroxide. Okay, like this, in this way, NH4 plus OH minus ions, and remaining Cl is there, and H plus is also there, so HCl can also form there into that solution. Okay, now to maintain the constant value of ionic product of water, and that's why after dissociation of water, concentration of hydrogen ions will be increases because OH minus ions will be attached with the NH4 plus, and remaining H plus ions will be more there, so the concentration of H plus ions will be more in the solution after the dissociation of water molecules, that will be the H plus and OH minus ion. So concentration of H plus ions will be more, so that you can easily say the solution becomes acidic in nature due to hydrogen ions, and therefore we can say the hydrolysis reaction of ammonium chloride is written as in this way: NH4Cl plus Cl minus plus H2O, and it gives NH4OH and Cl minus plus H plus. Okay, automatically you will say here OH minus is attached with the NH4 plus, so the excess amount of H plus will be present, so that whole solution will becomes acidic condition. Okay, now by cancelling the common ions, that is Cl minus, okay, here, okay, Cl minus is present at left hand side and also at right hand side, so we have to cancel them. So the remaining molecules will be here NH4 plus and H2O, and here NH4OH and H plus, and again we have to take here water molecule as a constant. So remaining molecules we have to apply the law at equilibrium and taking the water concentration as constant. So you will write in this way: KH, hydrolysis constant, that is concentration of product, okay, and divided by the concentration of reactant. Okay, so remaining only, okay, water molecule we can consider as a constant, and Cl will get cancelled, so remaining is NH4 plus only here, and that is the free base. Okay, NH4OH, that is free base, and this is the free acid. Concentration of free base and concentration of free acid divided by unhydrolyzed salt. And KS stands for, we have no hydrolysis constant of salt. And for this solution, if you give the temperature, so you will get the different values. Okay, now we have to see the ionization of weak base, that is NH4OH. This is the weak base. So the you will get separate ions, cations and anions, that is NH4 plus OH minus ions. And if you will apply the law, okay, for this reaction, so the ionization constant of weak base, so you will see ionization constant for the weak base, that is K small b, capital K small b, is equals to in bracket NH4 plus into in bracket OH minus, in bracket OH minus, and divided by in bracket NH4OH. And again we have to take ionization of pure water, that is H2O in liquid form. That ionization you will get H plus OH minus ions. And by the law it gives the ionic product of water, so that is Kw. We have no ionic product of water, we can denote it by Kw, and in bracket H plus OH minus ions. This is the ionization of water. Dividing the equation for the Kw and Kb, okay, ionization constant for the weak base and ionic product of water, Kw and Kb. So you will get Kw divided by Ka is equals to in bracket H plus OH minus, okay, concentration of OH minus, divided by in bracket NH4 plus into in bracket OH minus, okay, concentration of OH minus, divided by the concentration of NH4 plus. And next step here, KH is hydrolysis constant, and we will take here in bracket NH4 plus into in bracket H plus, and finally you will get hydrolysis constant is equals to KH, that is okay, Kw divided by Ka. And by using this formula we can say hydrolysis constant of salt, of strong acid and weak base is inversely proportional to the ionization constant of weak base, that is denoted by capital K small b. Now we have to see next topic, that is degree of hydrolysis. And again we have to consider the hydrolysis reaction of salt, and in that C, small c, is denoted by initial molar concentration of salt, and small h, that is the degree of hydrolysis of salt. And again fraction of total salt molecules that undergo hydrolysis at equilibrium. So you will take this reaction, right? So this concentration for the NH4Cl, okay, NH4Cl plus water molecules, so you will get NH4OH plus HCl, that we have known, okay. If you will add NH4Cl into the water, so you will get NH4OH plus HCl. So the initial molar concentration for the NH4Cl will be small c, and here NH4OH for the 0 and HCl is 0, and the concentration at equilibrium will be small c in bracket 1 minus H, and for the NH4OH small c H, and for the HCl again small c EH. And therefore hydrolysis constant, okay, KH is equals to in bracket NH4OH in bracket HCl and divided by NH4Cl, that is the concentration of product divided by the concentration of reactant. As it is term we have to write here, okay, and is equals to CH into CH divided by C in bracket 1 minus H, and is equals to here C This C and this C will get cancelled, so remaining C into H square divided by 1 minus H. And if H is very small, so as compared 1, so you will take 1 minus H is equals to 1, that is 1 minus H is approximately is equals to 1, and in this way you will write KH is equals to C into H square divided by 1 minus H, and after that you will get C into H square, and here degree of hydrolysis that is H is equals to under root of KH divided by small c. And for this equation you will see here the degree of hydrolysis of salt is inversely proportional to square root of molar concentration. Okay, so that combining the equation we get the another relation of degree of hydrolysis. Okay, so we have to combine this equation and KH hydrolysis constant, that is Kw divided by Kb. So you will get this term small h divided not divided is equals to under root of KH divided by C is equals to under root of Kw divided by Kb divided by C, whole term divided by C here. Okay, and remaining you will see here small h is equals to under root of Kw divided by Kb into C. So this equation we can use for the calculation of degree of hydrolysis of salt of strong acid and weak base at any concentration of salt by the knowing the ionization constant of weak base, that is Kb. Now we have to see pH for this kind of salt, and in this case due to hydrolysis of salt of strong acid and weak base, the salt solution becomes acidic because the hydrogen ions will be more in this solution, right? So therefore we can write in this way concentration of H plus is equals to small c into H, and substituting the value of equation. Okay, so you will get H plus, concentration of H plus is equals to C into under root of Kw divided by Kb into small c is equals to under root of Kw into C divided by Kb, and taking negative logarithm of both sides of this equation, so you will take negative logarithm for this both side, that is minus log in bracket H plus is equals to minus log under root of Kw into C divided by Kb is equals to minus log in bracket Kw into C divided by Kb. Okay, bracket complete. Okay, and 1 by 2 square root. Now to the next step, pH is equals to minus 1 by 2 log in bracket Kw into C divided by Kb is equals to minus 1 by 2 in bracket log Kw plus log C minus log Kb, and you will see here pH is equals to minus 1 by 2 in bracket minus log Kw minus log C plus log Kb. Now you will get at the last step pH is equals to 1 by 2 in bracket pKw minus pKb minus log C, and this equation we can use for the pH of salt of strong acid and weak base by knowing the concentration of salt ionic product of water, and ionization constant of weak base. So we can use the calculation for this kind of pH solution.